Produced by PI Media. Blockchain.
Hi, welcome to the Orbs podcast. My name is Nate Nelson. If you don't know how to cook, you shouldn't try making a filet mignon. If you haven't watched a game of ice hockey before, it would be a bad idea to suit up and get on the ice yourself. As in any domain, to have an honest discourse about blockchain, there's a certain knowledge base you have to have going in. You don't need to be an expert to talk someone's ear off about the newest cryptocurrency at a party. Trust me, I know firsthand. But you do need a grasp of the field's fundamentals. In this episode, I'm going to very briefly take you through some of the history of blockchain in order to help us properly understand the state of the industry today. I won't cover all there is to know. For that, you'll have to wait for the rest of the podcast. Rather, my goal is that, by the end of this episode, you'll know enough to be able to hold up your end of a blockchain conversation at a party. And the first place to start, when we're talking about where blockchain comes from, is to know that its building blocks predate the technology itself. You could argue, for instance, that BitTorrent, the peer-to-peer file-sharing platform, was a sort of godfather to blockchain as an idea. BitTorrent was created in 2001 and allowed for the transfer of significant data over the internet by taking the load off a single server trying to send a file to a client, and instead delegating that work to a network of computers who'd also downloaded that same file. In a way, the process of transferring a file online became decentralized. In merely the act of, say, illegally downloading a ripped copy of Shrek 2, a user engaged a whole network of computers around the world whose users had similarly terrible taste in movies. That's why when Bitcoin was proposed in a 2009 white paper, it was both revolutionary and not entirely unprecedented. The person or persons who conceived of and created the system is or are still unknown to the public, merely authoring their work under the moniker Satoshi Nakamoto. Nakamoto's greatest contribution to the world wasn't necessarily even his creation of a new form of currency or a new technology, but the application of some core ideas to solve the problem of consensus on a decentralized ledger in a streamlined, elegant, and secure way. I'll speak at length about consensus in a future episode of the podcast. Briefly though, Bitcoin's solution to consensus is a protocol called proof of work. Anytime two anonymous parties transfer some amount of Bitcoin, a third party, a miner as they're called, solves a complex mathematical problem in order to confirm the transaction. By mathematical problem, I don't mean high school algebra equations. These are hugely complex numerical puzzles solved not by humans, but by powerhouse computer systems. This system works only because it naturally dissuades scammers from trying to push through invalid transactions. If you tried, you would need more computing power than the rest of the network combined. It's equivalent to trying to rig a presidential election by personally voting more times than everyone else in the country combined. One of the greatest feats of Bitcoin has been its alleviating any doubt as to whether blockchain technology is indeed working or that it is secure enough to hold assets of great value. That Bitcoin holds billions of dollars in value today is evidence to the public trust it has been able to cultivate. And it did all this in a remarkable way, by creating an environment free of central governance where all nodes are equal but without assuming that they are all honest. Still, Bitcoin naturally has its flaws as a first-generation technology. Take proof of work as just one example, which is both an innovative approach to trustless consensus and a huge tax on the world's computing power, As of the publication of this podcast, it's estimated that about 0.3% of the entire world's computing resource is going to Bitcoin mining alone. That may sound like a small number, but think about it for a second. It's 0.3% of all of the 3 billion or so people with laptops and smartphones out there, all the servers running the world's biggest websites, everything. And Bitcoin is still considered an emerging entity. If it ever were to become a worldwide currency on par with fiats like the US dollar, the sheer computing power, environmental impact, and pure cost of maintaining the blockchain would just be mind-boggling. To get an industry point of view, I spoke with two experts on the matter.
I'm Leonid. Today I'm the VP R&D at Orbs.
Hey, I'm Steven Goldsmetter. I'm a PhD candidate at Princeton University, and I do most of my work in cryptocurrencies and cryptography relating to cryptocurrencies.
You'll be hearing from Leonid and Steven throughout the remainder of this episode. I asked them, Bitcoin was an amazing feat of engineering. Why did the blockchain space ultimately need to evolve past it?
You have this really great breakthrough technology, payments on blockchain, on distributed consensus, and people naturally ask themselves the questions of, okay, what else can we do with this breakthrough technology?
And the reason today Bitcoin is not necessarily there, every transaction in Bitcoin in average takes about 10 minutes until it's being confirmed by the network. This is an average, confirmation time. It can take sometimes, less, sometimes can take more. And as long as it's not confirmed, it's possible to do what's called a double spend. So, for example, I can send you $100 worth of Bitcoin to perform some transaction, but as long as it's not confirmed, I can actually send the same, worth of Bitcoin to other people or even to myself. And in some cases, I can actually make sure that if I'm sending this back to myself, then this is the transaction that's going to be processed, and you will find yourself without any payment.
Problems like this are preventing the system from being used in production for any purpose other than as an electronic alternative to stored gold. In fact, you could argue that Bitcoin works much better as a product than a technology. For these reasons, organizations of the past decade have been working on taking the core principles that made Bitcoin so successful and applying them to create more robust infrastructure solutions to decentralized systems. Enter Etherium. If Bitcoin was first-generation blockchain, Etherium is second. Ethereum's key innovation is quite simple. It was designed to separate the application and infrastructure layers of its blockchain environment. You can think of first and second generation blockchain like the difference between a cake and a salad. You look at a salad and there it is, a bowl of its mixed component parts. A cake out of the oven, however, hardly resembles its ingredients at all. It's built on eggs and flour, but you're not really eating eggs and flour, you're eating an emergent product. For Bitcoin, there is no line you could draw between the underlying blockchain technology it's built on and the cryptocurrency application running on top of it. It's why some people have a hard time fully grasping how Bitcoin works, and why most people who invest have at least some threshold of technical know-how regarding how blockchain works more generally. Ethereum is different. For starters, and this is something many people get wrong, Ethereum is not a cryptocurrency. It is the basis for many cryptocurrencies, including Ether, which many people refer to interchangeably with the Ethereum name itself. But Ethereum is not an application at all. It is rather a blockchain infrastructure upon which application developers can build. The infrastructure itself functions primarily through smart contracts, immutable pieces of software running in a decentralized manner over all the nodes in a network under the promise of a full consensus upon the execution of its terms. Smart contracts function in the digital space like physical contracts do in the real world, making certain that interactions in Ethereum work properly according to any two parties involved. Understanding where Ethereum diverges from Bitcoin is essential to shaping a view of the future of blockchain technology, because even though they're often referred to in the same sentences, they are quite different phenomena. Bitcoin, for one, is given much of the credit for last year's cryptocurrency boom, and rightly so. However, it's Ethereum that's largely credited for the recent proliferation in decentralized application development. That's because it's not as much a thing as an environment. In general terms, you can think of it like this. If Bitcoin is like dollars, Ethereum is like an economy, where different countries can each participate with their own sorts of dollars. Vitalik Buterin wasn't even 20 years old when he conceived of Ethereum, impressing many around the world and making this podcaster quite jealous in the process. As only a second-generation technology, though, his platform has been criticized by some for working better as a proof of concept than in its real-world application.
Ethereum, it's no secret that Ethereum has a scalability issue. In Ethereum, every miner has to verify the computation of every smart contract. And if you join the Ethereum system in 5 years from now and you want to verify that the blockchain is correct, you need to go ahead and just verify all computation from the past 5 years. The question is now, how do we get past the limits of Ethereum in terms of scalability? Sure, in theory, Ethereum can do, it's a Turing-complete language, it supports state, so you can do arbitrary computations, but you have a pretty restrictive gas limit, and there are certain classes of computations that you just can't do inside the Ethereum block and inside the Ethereum transaction because they're just too costly for the network. So the question is, how do we take it to the next step? Smart contracts are great. How can we do this in a way that scales and doesn't have the limitations of Ethereum?
It's also the case that high fees, network congestion, and low transaction throughput have made it difficult for medium to large app developers to scale up.
One problem, or maybe caveat with Ethereum, is since it's a multi-tenant platform, and everything is being processed sequentially, and also everywhere at the same time. Right, so for example, if I send an Ethereum transaction and we have about 20,000 Ethereum nodes, computers that are running Ethereum, all of them will need to process my transaction more or less at the same time in order for my transaction to confirm. This makes the network very expensive. So, which means that sometimes Ethereum fees are pretty expensive. So this model doesn't really work for many use cases. Imagine, like companies like Facebook or Google that want to build products on top of Ethereum. Imagine, that you want to post something on Facebook or, click a like button, and it's going to take a couple of hours until, this will actually be processed, if it's going to process. And you also need to pay $5 if you want to like someone's post. So this, unfortunately, doesn't make too much sense in this context.
The race is on then for a third generation of blockchain infrastructure, one which builds on the success of its predecessors while providing veritable marketplace solutions for real-world businesses.
Blockchain.
To get a sense of what the third generation of blockchain technologies might look like, I asked Leonid and Steven about the core features of today's blockchain platforms, particularly Ethereum being foremost among them, that could use improving. Interestingly enough, they gave me quite different responses. Here's Steven's own idea from an academic's point of view.
People originally started off with sort of building off-chain protocols because of the limitations of Bitcoin scripting language. When Ethereum came along, a lot of people moved over and said, we don't need those protocols anymore. We can just do things directly on-chain. And now people are sort of seeing the benefits of having things off-chain, even if they could be done on-chain. And I think that's going to be characterized the third generation of, let's move everything off of the blockchain and only leave on the blockchain the bare minimum that we need to make everything work. So I think in a sentence, the third generation will be characterized by moving things off-chain. And this relates directly both to scalability and to privacy.
And here's Leonid on how the third generation platform that he's helping to build now improves on the second generation models.
Orbs is a third generation because I think it's easy to compare how Orbs is improving compared to Ethereum. For example, if before, I said there's all these problems with fees, both on Bitcoin and Ethereum, Orbs provides a customizable fees model. So if you're Facebook, for example, and you don't want your users to pay fees, so for example, a company as Facebook can decide it's going to subsidize fees. On the other hand, another client can decide that not only that fees are required, but also every user has to have a minimal fee, some minimal amount of funds to be available in order to prevent spam. Another, I think, major problem, what we referred before is predictability. So we know that today, if you're going to, if I or you will we're going to create some kind of apps, right? My app might require a very low throughput, right? On the other hand, maybe you created the new Tinder and you require a massive amount of throughput. So in Orbs, if you need to every transaction to be confirmed, let's say one transaction per second, it's guaranteed to you. If you need, thousands, 10,000s of transactions per second, it will also be guaranteed, but, the network will cost you more. So this is also, I think, very novel. And I guess the third is privacy layer that the Orbs network is going to provide. So as you know today, both Ethereum and Bitcoin, they are public chains. They are pseudo-anonymous, but other than that, everything is visible. So imagine if tomorrow we're going to have players such as Facebook and Google, which might have some kind of animosity between them. We don't want for either of those companies basically to use the blockchain to interrupt or maybe to learn things that it's not supposed to about its competitor. So what we do in Orbs, we have a novel way to basically make sure not only we encrypt the transactions, we also make sure that it's impossible to see the contents of and the semantics of the transactions before it's too late. I mean, before there's a way for one of the players to interrupt it. So I think this is also very novel approach, and our academic paper will focus on it.
It seems that if there's one through line to what needs to be upgraded in today's blockchain space, it's the technology's practical use. The third generation of successful blockchain solutions will not only work well in theory, but in practice. To reach that point, however, blockchain engineers will have to do their duty to those that came before, taking influence from previous blockchain solutions to create the best possible product. For all this talk about its faults, Ethereum really is great and will have paved the way for future platforms to do bigger and better things. After discussing what needs changing in the blockchain space, I asked Leonid what features of Ethereum really do work and will make their way into the third generation.
We are, of course, since Bitcoin and Ethereum are phenomenal, networks, and I think, great feats of achievement. We are, there are some concepts that we, if it's ain't broken, don't change it, don't fix it. For example, Ethereum smart contracts. But in addition to that, we implement parts of our protocol as smart contracts as well. Or something, I think maybe what's referred to usually, sometimes in Silicon Valley, dog fooding. So not only that we provide smart contracts, we actually implement parts of the protocol using smart contracts.
Hopefully by now you have some sense of how the blockchain space has developed over the past decade. Next time someone at the office party punch table starts ranting to you about a new, revolutionary blockchain platform that will surely disrupt the market of insert industry here, remember that blockchain already has a deep history. Its innovations have never come to us in the form of overhyped ICOs and overconfident CEOs. Instead, it's design concepts that build off the work of computer scientists past, and intelligent implementation of such principles into a structure that just really works, no frills. The third generation of blockchain technology will not be revolutionary, it will be evolutionary. That's it for this episode. Thanks for listening. Feel free to write me at nate@podil.net. That's NATE@PODIL.net with any questions or comments, and leave us a review on iTunes. Until next time, this has been the Orbs podcast, and I'm Nate Nelson.
Blockchain. Produced by PI Media.